In this Q&A video, we're going to answer the question, how do I select the correct size of cable for a circuit? Now, just before we explain the answer to this question, please be aware that this video is one of a series that we've made on the subject of circuit design. They can be viewed individually, or you can click the link in the description below to view them as part of a free online training package to help you with your CPD, and you'll receive a certificate to prove that you've completed the course. Through this series of videos, we've been designing a circuit protected by an MCB from BG Electrical to supply a 9 kilowatt Fusion Comet electric boiler from the electric heating company. So how do we finally find the right size cable? Well, in the last video, the previous step was to calculate what the tabulated current carrying capacity of the cable would need to be. Remember, tabulated just means recorded in a table. So let's find those tables. We'll stick with Appendix F in the on-site guide. In tables F4 to F6, we find information on the current carrying capacity of cables. Tables F4 and F5 are subdivided into two separate tables, one covering current carrying capacity and one covering the voltage drop for the cables. Table F6 contains all the information in one place, so which of these tables are we going to use? Well, each one has a description as to what it covers. So F4 is single core, 70 degrees C thermoplastic PVC or thermosetting insulated cables, non-armoured, with or without sheath and with copper conductors, which we can immediately discount for our circuit because we're not using singles. Table F5 is close. It covers multi-core cables having thermoplastic PVC or thermosetting insulation, non-armoured with copper conductors. So that's getting closer to the description of our twin and CPC cable, but we can go one better and look at table F6, which covers 70 degrees C thermoplastic PVC insulated and sheathed flat cable with protective conductor with copper conductors. That's the exact cable that we're using. Now again, you may be wondering, which one of these would I use for SWA, as none of those tables seem to refer to it. And you're quite right, they don't. But there are other tables covering other cable types in BS 7671, and again, we'll look at those another time. So table F6 has the different ways that twin and CPC can be installed along the top, and we find there 4 reference methods for when cable is installed in a ceiling or wall stuffed with insulation, namely 100, 101, 102 and 103. If we're using these reference methods, we don't need to apply the insulation rating factor as previously discussed, as it's been taken account of in those figures already. However, our cable is going to be clipped directly to a surface and not surrounded by thermal insulation. This means it's going to be installed using reference method C, which we find in column 6. We know our cable needs to be able to carry 62.58 amps from our previous calculations, so we simply work our way down the table until we get to a number that is bigger than 62.58 amps. The first time we get over that is here, where we have 64. Running over to the corresponding cable size in column 1, you can see we have a value of 10 square millimeters. Therefore, we need to install a 10mm cable in order for it to effectively dissipate the heat that it generates under normal operation. Interestingly, these values are pretty close to each other, meaning that we'd want to make sure that none of our rating factors change during installation. For example, if we were to run a third cable in the group of conductors, we might find that it derates the cable to the point where we'd need to upgrade it to a larger size. It really emphasises the importance of good circuit design and sticking to that design during the on-site installation work. Okay, so we've found the size of cable that we need to install to supply our boiler. However, there are other things that we need to check before we can install that cable. These include the volt drop, the earth volt loop impedance of the circuit, and in some circumstances, if the size of the CPC is acceptable. But we're going to cover that in the next part of this training package, so please do make sure that you check that out when it gets released. And that concludes this initial series of videos on electrical design. If you found it helpful, why not click the link in the description below to complete our free training package on this subject to help you with your CPD, and that way you'll receive a certificate as well. All that remains in this video is to say thank you very much for watching.